Alright, so we're back and we've already done this. We use technology to kind of investigate the possibilities, and I've kind of put them in three different columns. So one possibility is our rational function has a horizontal asymptote, y equals 0, the x-axis. Another possibility is we have a horizontal asymptote, but it's some y equals L. And then another possibility is that we have an oblique. And what I usually do when we're face-to-face is I have my classes kind of break up and really take a look at this. So, what I'd like to try to do is have you guys do that, but kind of hard to do this through the internet, right? And I'm sitting here talking to myself. So let me just cut to the chase, all right? And it turns out that has everything to do with the degrees. All right, so what's the degree of the numerator and what's the degree of the denominator? So if you'll notice up here, right, the degree up in the numerator here is 0. Well, it's 2 down here. Here it's 1 and it's 2 down here. And here it's 1 and it's 2 down here. So to get this horizontal asymptote being the x-axis, it seems like the degree, well it is, the degree in the numerator is actually less than the degree in the denominator. That you can take to the bank, right? So when I'm looking at this, as soon as I notice that the degree upstairs is less than the degree downstairs, I know I have a horizontal asymptote, and I also now know that it's the x-axis, y equals 0. So that is how you can tell right away. Beats the heck out of the technology, right? And then of course the next one, if you'll take a look after hearing me say that, what do you notice about the next round, right? A horizontal asymptote being, some y equals L, right? You see something common in there, right, with regard to the degrees? Yeah, hopefully you're realizing that the degree in the numerator is actually equal to the degree in the denominator, right? Degree 1, degree 1, degree 1, degree 1, degree 2, degree 2. And what's taking over, the way you find out where that horizontal asymptote is remember x is getting large, positively or negatively. So once x starts to get really big, subtracting 3 or adding 4 is negligible. So this function starts behaving a lot like x over 2x. And of course, if you divide out the x, what you end up having is y equals a half. And so there was our our horizontal asymptote, as I kind of pointed out to you guys. Same thing here, right? As x gets big, these two terms are irrelevant. This is going to behave a lot like the dominating features in this, 2x over x, which gives us 2, which we observe to be our horizontal asymptote. And then here, I know there's an x, but at some point, like you even think of 10. If when x equals 10, this is already at 100. Subtracting 10 is pretty negligible. If x is equal to 100, this is 10,000, and that's 100. So eventually, these two terms right here are going to dominate. So x squared divided by x squared, well, that's basically 1, which basically gives us our horizontal asymptote. So when our degrees match, to find the horizontal asymptote, it's basically the lead coefficient divided by the lead coefficient, right? 1 over 2, 2 over 1, 1 over 1. So that is how you can find what that L is with regards to this little guy right there. And then last but not least, we know that degree of the numerator less than the denominator is a HA at the x-axis. If the degrees are the same, then we have a horizontal asymptote at some y equals L. So what's left? Well, the degree in the numerator is actually bigger than the degree in the denominator. And if you look at these guys, right, degree 2, degree 1, degree 2, degree 1, degree 3, degree 2, and that is why we ended up having slant asymptotes, because if we would actually perform the division, if we divided a degree 2 by a degree 1, we'd end up with a first degree. If we took a degree 2 and divided by a degree 1, we'd end up with the first degree. If we had a degree 3 and divided by a degree 2, we'd end up with the first degree. So to actually find the oblique, what we actually have to do is perform the actual division. And the quotient that we get ends up being the slant asymptote. All right, so I think these two are pretty obvious from the pictures we saw and then from the theory that I told you. So I'm going to, these are covered, but these we still have to figure out, right, what exactly was that line Well, I just told you how we're going to do it. We actually have to perform the division and look at the quotient. So I'm going to do that in another video coming soon, and then we'll compare that with the technology. All right, so be right back.